Hello everyone, welcome back to the class real time system. So today we are going to discuss about the mutual exclusion. What is a mutual exclusion? The mutual exclusion which is used in the multitasking operating system. Why the mutual exclusion which is used in multitasking operating system? So in multitasking operating system which allows the sharing of resource between the several concurrent active tasks. So this do not imply that resource can be used simultaneously. The use of the some resources restricted to only one task at a time. So that two tasks trying to write the some data area which is illustrated in the example here. So here one of the example which is given, the two software models. The two software model names which is called the bottle in count and then bottle out count. They are used in the count pulse instead of issued from the detector which observe the bottle entering and leaving the processing area. So one of the industry which is taken the product area. So it is entering and exiting. Okay, exiting from the that particular processing area. So the two models run as an independent task. The two tasks operate on the same variable, the bottle count, and then the model bottle in count which increments the variable, bottle out count decrements it. So the models are programmed into high level languages and relevant programming language which is used. Okay, so this is the program, high level program. Here you can see that the bottle count which is assigned to the bottle count plus 1 for bottle in count, and then bottle count is equal to bottle count minus 1 which is for the bottle out count. Okay, at the assembler code level, the high level instructions which becomes, so this is bottle in count program, this is bottle out count program. So the bottle in count program is nothing but the bottle count. It will be counted, that value will be loaded into the accumulator. So the accumulator which is incremented by 1, and whatever the accumulator value, that will be stored into the bottle count at the end. Similarly, in outside also the bottle out count, so the bottle count will be loaded into the load A accumulator. It will be subtracted, and the finally the out count will be sent to the bottle counter. Okay, so in this diagram example you can see here, initially the A register value which is equal to 0, doesn't know, it is an unknown value. So the load A comma bottle count, so I have taken this bottle count is equal to 10. So initially the A which contains the counter value which is equal to 10. Okay, at these lines the B which is executing, concurrent program which is executing, the second program which is executing, that is load A comma bottle count. So what is the bottle count? The count value is already we have the 10. So the 10 will be loaded into the accumulator, and the next is what? Subtracting 1. So it will be subtracted. So it will become 9. And the next is by operating system is here. So here the load the bottle counter comma A. So the A will be loaded, A which contains the value of 9. Okay, so here you can see this value of 9. Add counter, accumulator counter is equal to 9. So it will be added. So again it will become 10. But actually the counter value must be 11, but it contains the value of 10 here. So there is a overlapping one data into the another data. So that's why we are going for mutual exclusion. Mutual exclusion is nothing but, and it's providing the security to the resources. It providing the security to the resources. So to do that mutual exclusion, that can be expressed in the form of reminder, pre-protocol, and the critical section, post-protocol and reminder too. So the pre-protocol and post-protocols are necessary overhead need to be taken. I'll tell you what is the reminder 1 and reminder 2. So the reminder 1 and reminder 2 which represents a sequential code that does not require access to the particular resource or to a common area of the memory. So the critical section is nothing but the part of the code which must be protected from the interference from another task. So the pre-protocol and post-protocol, which is nothing but it's called before and after of the critical section, the code segment that will ensure that the critical section is executed so as to execute all other tasks. So what is the benefits of this concurrency and also a critical section and protocol? It must be a shorter than the reminder, as a reminder can be overlapped with other tasks. So this protocol which represents a overhead which has to be paid in order to obtain the concurrency, and there is a loose connection between the one task to the another task. That's why we are going for mutual exclusion. So in this, which is used as a primitive instruction. So the primitive instruction that cannot be divided and it cannot be used like that. Okay, so the one of the mutual exclusions is nothing but a semaphore, binary semaphore. So which was proposed by Diksha in 1968. Okay, so the binary semaphore, it is nothing but a condition flag. So what is a condition flag? Condition flag is nothing but an either yes or no. Okay, which records whether or not the resources are available. So what is a binary semaphore, which is represented by the variable s. So when s is equal to 1, the resource is available. When s is equal to 0, the resource is not available. Okay, so the task must be wait. So instead of the processor waiting time, the waiting for the resource to become unavailable, there must be a mechanism for suspending the running task and record it for the recording that it is waiting for the particular semaphore. So the typical mechanism is associated with the semaphore is a queue, the task that are waiting for a particular semaphore. So these are the three conditions of the binary semaphore, that is initialize, secure and release. So what is the initialize? Initializing the binary semaphore, and the v is nothing but an integer. So set the semaphore yes to the value of v when v is equal to 0, when v is equal to 1. Secure yes. So if s is equal to 1, then the set yes is equal to 0 and allow the task to processed, otherwise suspend the calling task. Okay, release yes. So if there is no task is waiting for the semaphore yes, then the then set s is equal to 1, otherwise it resumes any task that is waiting for the semaphore. So one of the example which is given by using a printer access. The printer is one of the resource. So the mutual exclusion program which is written here, the variable is nothing but a printer access. It's a semaphore, procedure task, begin, reminder 1. So in the structure you can see here the reminder, it started with a reminder 1 and secure the printer access. So and if the printer is not available, the task will be suspended at this point, or otherwise the printer is available in the critical section and do the output and release the printer access and reminder to end task. So if you can see this, the structure reminder 1 and reminder 2 will be the top and bottom, and the critical section is nothing but an allocating the printer, whether if it is available it will allocate, or whether if it is not available it will not be allocated, whether if it is available then do the outputs. So this is nothing but a critical section, and the pre-protocol and post-protocol is nothing but it's securing the critical section. So it secure the print access and also you release the print access. So this is what the structure which is represented in the semaphore. Okay, and here if you can see here it is an initialize the printer access. So what is the value? Printer access value is equal to 1 because the resource is available, and the task A it's an active secure. So the task A is requesting the printer access. So that value, the printer access value will become 0. Now the task A which suspends, and the task B it is active secure. That means it requesting a resource. The task B will be in the queue, and then head and tail which are representing the task B here. Okay. Now the task B is suspended and place it into the printer access queue, and then task C is runs attempt to secure the printer access. Now the printer access value is equal to 0, head and tail it is pointing to the task B and task C. Okay, now the task C is suspended and added to the printer access queue. Now the task A which runs and release the printer, and it will be allocated to the task B. So the task B which is executing under the queue, now the task C, the heading to the point is task C here. So the task C is removed from the printer access queue and that will be placed into the ready queue. And the task B which runs and release the printer, so in that time the task C will be transferred from the printer access queue to the ready queue. And then task C runs and release the printer. Now the printer is ready to give any other task, so that value is equal to 1. So this is the one of the examples of printer access. And this is nothing but monitor. Monitor is nothing but a semaphore. It's one of the semaphore, another type of the semaphore. So the semaphore has a weakness. In use, they are scattered around the code. Each task that requires access to the particular resource has to be know the details of the semaphore. So the monitor is nothing but a set of procedure that provides the access to the data or to your device. So the procedures are encapsulated inside the model that has a special property that only one task at a time can be actively executing a monitor procedure. If placing a fence around the critical data, the operation that has to be performed. So critical data, so these are the fence which is around this critical data, and these are the control signals. So this is one of the general monitor. So here you can see here it is nothing but a resource. These are the gate levels. In that gate level there are number of tasks which is ready to accept the ready to use this particular resource. So among these tasks, the T5, T15, T16, T2, in that the T15 will be selected for using the resource. So in this condition the T4 and T6 will be suspended and waiting for the condition A to access the resource. So this is what the monitor monitor, which represents either the user task which communicates with the monitor rather than directly with the resource. So the two procedures are write data and then read data that provide the access to the data. Okay, so the monitor which prevents any other form of the access to the critical data. Okay, so the task wishing to write the data called the procedure write data, as long as no other task is already accessing the monitor, it will allow to enter the write data, write new data. Okay, if any other tasks are already using the write data or read data operations, that would be halted at the gate or suspended. That are only one task at the time to allowed within the monitor fence. Okay, so among these three entry points, okay, the T15 which will be gained entry, T2 and T16 is waiting for the entry points. So the two task is previously entered that has been suspended waiting for the condition A. So the advantages of the monitor over the semaphore is other methods, that is exclusive implicit. Only actions are required by the programmer of the task which is requiring to use the resource invoke entry. Okay, so this is what the semaphore. And intertask communication. So I told you that in the multitasking operating system there is a intertask communication between the process. So that intertask synchronization and communication, there are three areas: synchronization without data transfer without synchronization, synchronization with data transfer. So among this we have only the synchronization without data transfer. That means there is a synchronization between the transmitter and receiver, no need to transfer the data. So frequently one wishes to able to inform the another task that an event has occurred, or to set a task to wait for an event to occur. No data need to be exchanged. A mechanism that enables this is called a signal. A signal is defined as a binary value such that if S is equal to 1, that signal has to be sent but has not yet been received. So associated with the signal is in queue, permission operations are required. So that will be required by initialize, wait and send. So initialize is nothing but initializing the signal value to 0, and wait is nothing but when S is equal to 1, then S is equal to 0, will suspend the calling task and place it into the condition queue, and send the condition queue S is an empty, then S is equal to 1, else transfer the first task in the condition queue and ready to the accept the queue. So the clearly it is similar to the semaphore. It is different is not implementation but how they are used. A semaphore which is used to secure and release the resources, as such calls will be made. It's only one task. The signal is used to synchronize the activity. The two tasks, one task will be issued and sent and the other task will be in the waiting queue. So standard and wait is an indefinite wait, hence charges to be made in the real-time operating system. Okay, so these are the resource references. So far we have discussed about what is a semaphore. In that semaphore we have discussed about binary semaphore and also a monitor, and intertask communication we have discussed about. I hope this video is very helpful for you. We'll meet you in the next video. Thank you all.